So this question was about number 6 through 8 on 8.5 homework. So we'll start with number 6 and go through that. So 49 and 7 are my bases, and I could technically rewrite this. I'm gonna circle them both and notice how they both have a 7 in common. So I'm gonna put a 7 here and a 7 here. Now, to get from 7 to 49, I would raise that to the second power. To get from 7 to square root of 7, I would have to raise that to the 1/2 power. And from there, I'm going to rewrite the x minus 2 and distribute. So 2x minus 4 equals 1/2. From there, it's a lot easier to go ahead and get rid of the fraction completely. And so just a little trick that I do to get rid of fractions, and it makes solving a million times easier, is I'm just going to go ahead and multiply everything by 2. Because I can combine the 4 and the 1/2, but if I don't have to, then that would make life easier. So this is totally acceptable, and since it's an equation, if I do one thing to the left, I have to do it to the right. But if I multiply everything by 2, I have 4x minus 8 equals 1. And then I now combine like terms, so 4x equals 9, x equals 9 over 4. Now if you combine the 4 and the 1/2, found common denominator, then divided by 2, you would end up getting the same answer. So if I showed you that, you would get 4 plus 1/2, which would end up being 8 over 2 plus 1 over 2, which would be 9 over 2. Divide by 2. Divide by 2. Or multiply by 1/2, I guess. Same thing. You get 9 over 4. So this way is a lot harder and takes longer, and you have more room for error. I like this method better because you can get rid of the fraction from the beginning and then solve. Okay, number 7. So this has an x in a different place. We're still solving for x here. So x is now in the base. So if the rule applies where your bases are the same, so if bases are the same, then you need to set the exponents equal to each other. If your exponents are the same, then you can set the bases equal to each other. So kind of the reverse of that. And so right now, my exponents are m and m over 2. So if I look at the right side, the m over 2, it's like if I have a fraction, if I wanted to get rid of this over 2, then it would be like I were square rooting it, right? So kind of like what we did in number 6. So if I said 7 to the 1/2 is the same thing as the square root of 7, then 9 over 4 to the m over 2 is the same as the square root of 9 over 4 to the m power. So all I'm doing is, instead of having the 1/2, as an exponent, I'm now just putting it as a square root, and they're the same thing. So if I actually go through and square root this, then you have 3 over 2 to the m, and then x to the m. So since they're both to the m power, they're the same exponents, I can say that x equals 3 over 2, and they're the same thing. And if you wanted to test it out and plug it back in, you could do that as well. And you could even choose a different number for m, choose any number for m, like 1 or something like that, and just test it in your calculator. Okay, the next one is number 8. And so on number 8, now my x's are back in the exponent. And I can't see the right of it, so I'm going to scooch it over a little bit. So I'm looking at what they both have in common. Well, they both have an m in common. So I'm going to put an m here and an m here. Now, in order to get from m to square root of m, I have to raise it to the 1/2 power. In order to get from m to 1/m squared, I would raise it to the -2 power. So that's just me rewriting these two. M to the 1/2, m to the -2. And I obviously still have to copy these down. So put it in parentheses, x minus 4, 2x plus 1. When I distribute, I get 1/2 x minus 2 equals -4x minus 2. And just like number 6, I have this 1/2 that I don't like. So it is acceptable to multiply both sides by 2. Perfectly allowed. So when I do that, 2's will cancel and I have 1x minus 4 equals -8x minus 4. Then I combine like terms, so 9x equals 0, which is kind of sad. But after all that, I end up getting x equals 0.